Hey folks, in this video we're going to do a challenging problem having to do with conditional probability and expected value and a lot of the concepts that we've looked at to this point. Now, really want to emphasize this is a challenging problem, and if you can't get it on your own, don't sweat it. Of course, if you want to give it a shot, be my guest. You've got all the information that you need on this screen right now, so you can pause and work it through on your own. But like I said, I don't expect you to all to be able to solve this problem at this point. But I do think it's a nice illustration of a lot of the concepts we've covered thus far, sort of bringing it all together. So let's take a look. We're running a company and we launch new products. And before we launch each product, we have our market research department make a prediction about whether that product is going to be successful or not. That's the basic scenario. And up here we have a table of possible results that I put together. So this is based on historic information about our new product launches. We know that about 20% of our new products have a good result, which with an average return of about $2.5 million to us in profit. 40% of our products turn out average, and they have just a little bit of a positive return, $100,000 on average. And 40% of our products flop. They don't turn out well at all, and they lose us $1.5 million. We have three possible predictions from our market research department. They can either predict a good result, predict an average result, or predict a bad result. And this table shows us how often they make each of those predictions depending on whether the product is really going to be good, average, or bad. So for a good product, they're predicting that it's going to turn out good 40% of the time. They're going to predict that it turns out average 50% of the time, and they're going to predict that it's a bad product 10% of the time. All when it really is a good product. You can see from this table, they sort of, looks like our market research department likes to hedge its bets. They tend to predict average more often than anything else. So something to keep in mind. What we want to know is, for what predictions from the marketing department should we launch a new product? You know, you can sort of, if the marketing department is halfway competent, you can probably say, yeah, I'm guessing when they say good, it should probably go. Certainly when they say bad, it's probably a bad idea to launch because, you know, when we have a bad product, it's likely to lose us some money. But what about when they say average? It's hard to know. So we need to look at their results. And this table is going to be really key. What is this table? What are these results telling us? What are these numbers? Well, hopefully some of you have identified that these are conditional probabilities. They are saying when the product is good, if good is our condition, then these are our possibilities of predicting good, predicting average, or predicting bad. These are all conditional probabilities. If event A is predicting good, and event B is it actually is good, then what we're saying is, what is A given B? And it's 40%. All right, so you know that my go-to is to create decision trees, so let's do that. I like to start with the thing that's sort of set in stone, which is, in this case, whether the product is actually a good product, whether it's actually going to work in the marketplace, whether it's average or whether it's bad. So let's start there. We begin with a three-pronged decision tree. Let me make that a little bit longer. And give myself a little bit more space to work with. Bad start. It's already looking ugly. So we have good, average, and bad. This happens 20% of the time, this happens 40% of the time, and bad happens 40% of the time. We have three possible predictions for each of these. We have I'm going to call this PG, PA, PB, all the way through. PG, PA. If I make it sloppy down here, you'll know because I've gone good, average, bad. Just remember that. PG, PA, PB. All right. Predicting good, when we know that the product is good, is going to happen 40% of the time. 0.4. Predicting average when we know the product's good is going to be 0.5, and then 0.1. you see where I'm going with this. This is going, when the product is average, we're going to predict good 25% of the time. I'm going to go below the line in this case. This is going to be 0.6, and this is going to be 0.15. You all with me so far? Well, since you can't answer, I'm going to take that as a yes. When the product is bad, the prediction that it's going to be good happens 20% of the time. You predict average 50% and predict bad 30%. All right, so now we have this tree almost all filled out. Notice something here. In past examples, sometimes what we've been given is the intersections, but not the conditional probabilities. In this case, we're actually given the conditional probabilities, but not the intersections. Either one's pretty easy to calculate if you know the other one. So in this case, we're going to calculate the intersections. We want to know, out of all of our products, what's the probability that it will both be good and predicted as good? Well, that's just going to be 0.2 times 0.4. So I'm going to call this good, comma, PG. Let me just fill this out real quick. Good, comma, PA, good, comma, PB, just so we can easily reference this again. A, comma, PG, A, comma, PA, A, comma, PB, B, comma. Thanks for bearing with me through this. PA and B, comma, PB. All right. So let's calculate these probabilities. 0.2 times 0.4 is 0.08. 0.2 times 0.5 is 0.10. 0.2 times 0.1 is 0.02. All of this should add up to 0.2, and it does. Good, we're moving on. 0.4 times 0.25 is 0.1. 0.4 times 0.6 is 0.24. And 0.4 times 0.15 is 0.06. That all adds up to 0.4. Looking good so far. 0.08, 0.20, 0.12. Again, everything's checking out. Now, where do we go? So for our next step, we actually need to tie in the market research predictions to returns. We need some way to say, okay, this is how often the market research department is predicting good, and what does that actually translate to in terms of possible returns? We can do that now. Well, this goes back to expected value, and I'm going to remind you of that in a moment, but we can do things like tell how often the market research department is predicting good using our decision tree, because we can say, well, the number of times they're predicting good when it's good, 0.08, plus when it's average, 0.1, and when it's bad, 0.08. So we can say, yeah, add those three together, and we get 0.26. That's how frequently, 26% of the time, the market research department is actually predicting it's going to be a good product, even though only 20% of the actual products are going to be good. So for the next step, I'm moved our decision tree over so that we can view it while we're working in Microsoft Excel, because we're going to have to use Excel. I mean, you could do this by hand as well, but I like Excel a whole lot better for doing expected value. So I've made this new table here. It's actual performance versus what the prediction was. We didn't have that yet. We had the conditional probabilities over here when it was good. And we had the conditional probability saying if the product, the actual performance of the product is the condition, how often are we making these predictions? But now we're going to look at the opposite, which is when we actually make a prediction, how often do we have a specific product happening? So like when we predict good, how often is good coming up? So looking up here, we say when the prediction is good, it's good actually 0.08 out of 0.08 plus 0.1 plus 0.08. Those are all the circumstances under which we would get a good prediction. When it's good, when it's average, when it's bad. And that's what we just talked about a minute ago. So this is conditional probability. This is straight conditional probability. These are the outcomes we're looking for, 0.08 up here, over the total possible outcomes. And again, we're restricted to just when we've predicted good. So predicted good here, here, and here. All right, we're going to move quicker through the rest of this. Oh, and I forgot to put my equal sign. That's just as well. It made it easier to view. Now, this denominator is going to be the same when we move over to average, right? Now we're saying, okay, predicting good is going to happen 26% of the time. That's 0.08 plus 0.1 plus 0.08. So now I just need to change the numerator around. So this is going to be equals 0.1 average predicting good divided by 0.26. Same thing we just did. And here this is going to be 0.08 from down here divided by 0.26. Notice, this all sums up to 1. All right, we're going to do the exact same concept down here. Predicting average when it is good happens 0.1% of the time. Sorry, happens 10% of the time. And we can divide that by 10% plus 24% plus 20%. We have the exact same denominator here, which is 0.54. 54% of the time, they're actually predicting average. Exact same denominator, but now our numerator is just going to change. So they're predicting average when it actually is average 24% of the time. And here we're getting 0.2 divided by 0.54. Again, I'm going to do a quick sanity check. Does this all add up to 1? It does. Lovely. By the way, these are just enormous decimals. It bothers my aesthetic a little bit. Okay, that ought to be a little bit more manageable. Now, exact same concept here. We've got 0.02 divided by 0.02 plus 0.06 plus 0.12. I'm actually just going to do this in my head. 0.12 plus 0.06 plus 0.02 is going to be equal to 20%. And again, sums up to 1. All right. So now we have the other conditional probabilities. These are the probabilities that say, okay, if the prediction was good, what are the chances that it actually is good, that it actually is bad, or average, or that it's bad? If the prediction was bad, what's the probability that it actually is good, probability that's actually average, or probability the product is actually bad? We're almost there. Thank you for bearing with me thus far. I know this is a long video. Now we need those actual returns, right? We need to use expected value to calculate the returns because we got almost everything. Using the returns, we can say, okay, if the prediction is good, what is our expected value? And we get that. Let's go back and remind ourselves what the returns are. Okay, if the product is good, we get a return of 2.5 million. If the product is bad, I mean average, we get a return of 100,000. If the product is bad, we get a return of negative 1.5 million. So let's write those down. And actually, let's go and make these all dollars and then reduce the decimal places. Okay. I'm going to put a new column over here called returns. And here we need to use these numbers. If the product's good, we know that it's going to be equal to 2.5 million for us. But we have to add that to the possibility that it's average times the return if it's average, plus probability that it's bad times the return if it's bad. Therefore, our expected value, if the prediction says this is going to be a good product, is $346,000. Let's do the same thing if it's an average. Actually, I'll skip that because that's the thing that we're most unsure about. Let's just do bad real quick. We know if they've predicted bad, it's only going to be good 10% of the time, so we'll multiply that times the outcome if it's good, plus probability that's average times the outcome if it's average, plus probability that's bad times the outcome that's bad. Now I know some of you have some Excel shortcuts that can make this a whole lot faster, but I think it's important for us to go through this step by step so everyone sees where we're going with this. All right, so clearly if the prediction is bad, we don't want to invest in that product. But let's see about what if the prediction is average. We're multiplying good times a return of 2.5 million, probability that it is average times a return of 400,000, plus probability that it is bad times the return if it is bad. And we can see that the return, if the prediction is average, is slightly negative. We probably don't want to take a chance because the expected value when the marketing department has predicted an average product is actually slightly negative. So the only time we want to make an investment in this product is if the prediction says good. And this is maybe a little bit surprising to some of you because you can see that with an average product, the return is $100,000. But the marketing department is not entirely accurate. So they hedge a little bit high, it looks like, in making their predictions. So we only want to invest when they've said it's a good product. And we can expect our expected value on investing on a product the marketing department has said is good is about $350,000. All right, thank you for bearing with me. I know this was a lot to take in.